Hello everyone. So this is question number 6 from 970953 October November 2022. Okay, so let's see this. Find the number of different arrangements of 9 letters in the word activated. So if we notice we have 2 A's and 2 T's, right? So this means that different arrangements would be 9 factorial divided by 2 factorial, 2 factorial. So 9 factorial divided by 4, that is 90720. B part. Find the number of different arrangements of 9 letters in the word activated in which there are at least 5 letters between the two ways. So at least 5 letters between the two ways. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, let's compare the scenarios. Okay, so let's just bring it a little bit over here just to see this. So at least 5 letters, so that means 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, sorry, 1, 2, 3, 6 over here, and then 7. So somewhat like this. So that means 5 letters in between the two ways, 6 letters between the two ways, and then 7 letters between the two ways. Now that means 2 A's are already selected uh, from these letters. So that means we have 7 letters to choose from. So the last one is pretty easy. So this is just 7 factorial divided by 2 factorial because we have to duplicate t's. Now consider the second one. Now if we consider this whole A block to be 1, that means we have 1 unit, 2 units. And we still have 7 letters. That can be any of those 7 letters. So 7 factorial divided by 2 factorial as for the third one times by 2 factorial because we have 2 units. This whole A block is 1 unit. We'll consider that 1 unit. Similarly, again, we have 3 blocks and 7 letters to choose from. So 7 factorial divided by 2 factorial times by 3 factorial. So 7 factorial divided by 2 factorial, that is 2520. And since we are going to be adding them because they are different OR cases, like 5 letters in between A or 6 letters between A or 7 letters between them A. So we'll be adding them up. So this just simply becomes 7 factorial divided by 2 factorial times by 3 plus 2 plus 1. So 6. So times by 6. 15120. Right. Okay, moving on. 5 letters are selected at random from 9 letters in the word activated. Find the probability that the selection does not contain more T's than A's. That means the number of A's is greater or equal to number of T's. Or we can also say that number of T's is less than or equal to number of A's, basically. So let's make a table of different possible scenarios we can get for those T's and A's. If I have 0 T's, I can have 0 A's. If I have 0 T's, I can have 1 A. If I have 0 T, I can still have 2 A's, but not more than that, obviously. Then if I have 1t, I can have 1a, 1t, 2 are also acceptable. If I have 2t's, I need to have 2a's also. So now let's see their combinations. Again, we're talking about the selections in general, not um, the rest, basically. Now, one thing to notice over here, uh, when we have 0t's and 0a, that means from the we have 2t's, we have 2a's, and 5 others, basically. So now we have 2c0 because none of the a's and t's are selected. But from the other 5, 9 minus 4, 5, we are selecting all of them. Similarly, 2c0 times by 2c1 times by 5c4 because now you're selecting 4. 2c0 times by 2c2 times by 5c3. 2c1 times by 2c1 times by 5c3 again. 2c1 times by 2c2 times by 5. Now we have 3 already selected, so that means I need to select 2. 2c2, 2c2, and then 5c1. So 2c0, it's 1. 2c1 is 2. And 2c2 is also 1. So 0, 2, and 1. So, and same goes for, so when I have 2c0, 1 times by 1, 1 times by 2, 1 times by 1, 2 times by 2, 2 times by 1, and then 1 times by 1. Now let's look at the 5c's basically. So 5c5 is just going to be 1 basically. 5c4 is going to be 5. 5c3 and 5c2 will be equal. So 10, 10, 10. And 5c1 is just 5. Right? So we need to total them up first. So which is 1, this is 10, this is 10, this is 40, this is 20, this is 5. So now the total is 1 plus 10, 10 plus 10, 20, plus 40, 60, 80, 85, and 86. Now, since we are asked about the probability of selection, so what we'll do is the total, so the probability will be equal to 86 divided by all the possible combinations from the 9 letters, 9C5. So 86 divided by 9C5. That is equal to 43 over 63. Yeah, so this is it, and that's the end of the question. All right, so see you in the next question. Bye-bye.